Hello students, today I will discuss on friction. I will discuss the concept and some important derivations on friction. So what is friction? Friction is the opposing force which resists or obstructs the relative motion between the two bodies. So if applied force is in the eastward, then frictional force will be in the westward direction. So just in the opposite direction. So applied force and frictional force, between them the angle is 180 degrees. Now here this is the body. This is a body kept on a surface. This is the body kept on a surface. The weight W is acting in the downward direction, and there is one reaction upwards. That reaction is called normal reaction. P is the applied force, F is the frictional force. It is found from the experiment that frictional force is directly proportional to the normal reaction. That is, when the frictional force increases, normal reaction also increases. Therefore, we can write F is equal to mu n, where mu is a constant of variation. Now this mu is known as the coefficient of friction. Mu is called coefficient of friction. And from this relation 1, we can see that mu is equal to F by N. So we can easily define mu, that is coefficient of friction is the ratio of force of friction and the normal reaction. Coefficient of friction mu is equal to the force of friction, the ratio of force of friction and the normal reaction. So it has no unit, because force of friction, that is a force, and normal reaction, that is a force. So if it is Newton, that is Newton, those will be cancelled. So mu is a pure number. It has no unit. So F is equal to mu n we get. Now another important concept, angle of friction. Here we can see that between the normal reaction and the force of friction, there is a resultant R. And if we draw the parallelogram law, if we apply the parallelogram law, then the angle between the resultant vector R and the normal reaction, that is called the angle of friction. R is found from N and F. Again, the angle between R and N, that is resultant vector and the normal reaction, that is the angle of friction, and that is denoted generally by lambda. From the geometry of the figure, we can, or trigonometry of the figure, if we apply trigonometry here, then perpendicular by this perpendicular, this base, perpendicular is F and base is N. So F by N is equal to tan lambda. Again, F by N is what? Mu. So we can write tan lambda is equal to mu. So that is another important relation. Next, this one. This one, a body is falling. A body is kept on the, not falling, is kept on the inclined plane. Now, the inclination is changed. The inclination is changed, and at one time it just tends to fall. So that maximum angle of the inclined plane, that is called angle of repose. Repose means at rest. So maximum angle of the inclined plane for which it is at rest is called angle of repose, and generally is denoted by theta. Now, mg is the weight that acts vertically downwards, there is no doubt of it. And from here, mg cos theta and mg sin theta will be the components. Mg cos theta will balance the normal reaction, and mg sin theta will balance the F, the force of friction. So we can write mg sin theta So we can write mg sin theta is equal to f and mg cos theta is equal to n. If I divide, we are getting tan theta is equal to f by n. That is another important relation. That is another important relation. Now if we equate relation 2 and 3, we are getting tan lambda is equal to tan theta. Therefore lambda is equal to theta. This is another important relation, that is angle of repose is equal to the angle of friction. Hope you have understood. Try to subscribe my channel and give like wherever is possible. Thank you.